got to be quiet and pay attention still. Okay? So we're going to talk about special right triangles today. Okay? These special right triangles can be solved without the use of a calculator. So you should not have a calculator whatsoever with you when you do this note sheet or this assignment. Okay? 0% calculator.
It's all mental math.
Yeah.
Yay.
Okay, so first I'm going to kind of prove why we can use these formulas that we're going to be using for our special right triangles. The first one has to do with a square. So what do you know about a square? Raise your hand, don't shout it out. What do you know about a square, Max?
It has 4 equal sides.
It has 4 equal sides, right?
Yeah, I want to start off. Don't treat me like I'm like a shh.
What else do we know about a square?
All sides are right angles.
All the angles are right angles. That's good. Okay, if they are right angles, they are 90 degrees, right? So what I'm going to do, I want to split this into 2 triangles. So I'm going to draw a diagonal through my square. Okay, so I split this into 2 right triangles. Notice how your right triangle has 2 equal sides, just like your square had 4 equal sides. Okay? Now this angle that I drew my diagonal through, each of those angles are 45 degrees. Okay, that diagonal split those in half. So instead of 90, they're now 45. Okay, so here I have my right triangle. It is a 45, 45, 90 degree right triangle. So I'm going to label each of these sides. Opposite the 90 degree angle, so across from it, that is your hypotenuse. Okay, so that's our hypotenuse. The other 2 sides, which are congruent, are the legs of your right triangle. Okay, I'm going to kind of derive the rules that we're going to be using using the Pythagorean theorem. So that's, again, a squared plus b squared is equal to c squared. Okay, instead of leg, I'm going to label each of these x. Okay, and they're both x just because our legs are congruent. So I can label them both the same thing. So for a squared and b squared, I'm going to plug in x and x. So we have x squared plus x squared is equal to our c squared value, which is our hypotenuse. I'm just going to abbreviate hypotenuse and square that. Just bear with me. So I can combine like terms on the left-hand side. Okay, I have 2x squared. Okay, that's equal to the hypotenuse squared.
We just call it hype now.
I'm now just going to solve for the hypotenuse, so I'm going to take the square root of both sides. Okay, I can't take the square root of 2 evenly. Okay, you'll get a really long decimal. So I'm going to leave that as the square root of 2. But I can take the square root of x squared, right? What do I get when I take the square root of x squared? X. Okay, then the hypotenuse, the square root of the hypotenuse squared is just the hypotenuse. Now remember, I labeled this x as one of my legs. I'm going to replace x with the word leg again. So we have the square root of 2 times the length of one of our legs is going to equal our hypotenuse's length. That's the rule we're going to use to find different lengths of right triangles. Okay, so if you have the hypotenuse, or if you have one of the legs of a 45, 45, 90 right triangle, you can find the other side. Okay, so this is the rule we're going to be using. That's how that's derived. So if we look below here where it says 45, 45, 90, triangle theorem, we have our legs are congruent. Move up a little more. We have our legs are congruent in this right triangle. Those are labeled L. And then the hypotenuse is taking that leg, which is L, and multiplying it by the square root of 2. Okay, so over to the right here, I'm going to rewrite our rule. So we have the hypotenuse is equal to the square root of 2 times a leg. This is your formula. Okay, make sure you have that written down. Now, say I was given the hypotenuse, but I wasn't given the leg. Okay, and I had to find what the leg length would be. Well, I would just plug in my hypotenuse here, the number that it gave me, such as 10. Okay, say your hypotenuse is 10. I would plug in 10 for hypotenuse, and then I just solve my equation for that leg. Okay, does that make sense? It'll make more sense once we do some examples. Okay, so we're going to do an example of this just so you can see what's going on. So number 1, this triangle. First I have to identify that it is a 45, 45, 90 right triangle. Well, I know this is 90 degrees. This angle is 45 degrees. That means this angle also has to be 45 degrees. Okay, so this is our special right triangle. Next, I want to locate the hypotenuse and both of my legs. Okay, hypotenuse is opposite that 90-degree angle. Again, I'm going to abbreviate, so that's our hypotenuse. The other two sides are your legs. So in this case, I am given a leg measure, and I need to find the hypotenuse because I want to solve for x. So using our equation here, I'm just going to plug in what we know. Okay, hypotenuse, I would plug in x. Then I have equals. Next is the square root of 2 times the leg length. Okay, the leg length is 6. Okay, I'm just going to rewrite this to make it look better. So our x value is going to equal 6 times the square root of 2. That's your answer.
That's easy.
Okay, that's just your answer. You leave it in that square root form. Okay, don't plug it into your calculator and get a decimal. No calculators today at all.
Thank you.
Questions? All right, number 2, we're going to do the same process here. Here in this one, if I know both of the leg lengths of my right triangle are the same or congruent, that means it also has to be a 45, 45, 90 right triangle. Okay, so if your legs are congruent to each other, this rule still applies. Okay, next I'm going to label my sides. So opposite the 90-degree angle or across from it is your hypotenuse. The other two sides of that right triangle are your legs. And again, I'm just going to use our rule up here and plug in what I know. Okay, so here hypotenuse. My hypotenuse is x. Next I have the square root of 2. That never changes. Times our leg length. Okay, our leg length is 9 times the square root of 2.
Not the answer.
No. Here, if I multiply square root of 2 times square root of 2, what do I get?
2.
You get 2. So I have 2 times 9. So x will be 18. Questions?
Can we do one?
Do number 3. Make sure the person next to you has the same answer as you do. Check with somebody behind you.
I think we can do number 4 too. I think we can do all these.
You could try. If you feel comfortable, you go ahead and try. All right, coming back.
My calculations are correct.
Coming back.
Number 4 should equal 10. Yeah, it should.
All right. For number 3, as I walked around, most people had this correct. You should have x is equal to 4 times the square root of 2. Okay, 4 times the square root of 2. Shh. We're getting quiet now again. Any questions on this before I move on? All right. Then, looking at number 4, we're going to do, again, the same process here. This side is also supposed to be x so that you know those two sides are congruent to each other. Okay, since those two sides are congruent, this is a 45, 45, 90 right triangle. That is important because on your assignment, you'll have to determine which special right triangle it is. Okay, so always look at your angles first. From here, I'm going to label my sides. So across from the 90-degree angle is your hypotenuse. My other two sides then are the legs. And again, I'm just going to plug in each thing for my rule up above. So first is my hypotenuse. This time I have a number instead of x. So I'm going to plug in 5 times the square root of 2. Okay, that's equal to the square root of 2 times our leg, and this time our leg is x. So this time I just set up an equation. Now I have to solve for x. Okay, so if I have something multiplied by x, what should I do to get x by itself?
Subtract x.
Divide. So I'm going to divide both sides by the square root of 2. So here on the right side they cancel. What happened on the left side? What are they going to do? They're going to cancel each other out too. I have the square root of 2 over the square root of 2. So my x value then
X equals 5.
will just be 5.
Do number 5.
I'm going to do number 5. All right, so same thing in 5. Label your sides. Hypotenuse. Leg. Leg. Plug into your rule. Okay, this time I have the hypotenuse again. So for hypotenuse, I have 12 is equal to the square root of 2 times our leg length. Our leg length is x. So just like the last one, I'm going to divide that square root of 2 out from both sides. On the right side, they cancel. Okay, so I have right now 12 divided by the square root of 2 is equal to x. Now remember, when we were simplifying our radicals, okay, this was part of your assignment that was due today. What do I have to do to rationalize the denominator? You want to multiply by a version of 1. That is the denominator. Okay, so I'm going to multiply by the square root of 2 over the square root of 2. Okay, so multiplying straight across here, I have 12 square roots of 2 divided by square root of 2 times square root of 2. Your root should cancel out when you do that. Okay, that's why we want to multiply by that number. That root cancels out. Okay, so I should just end up with 2. Now, can I simplify this further?
You could.
I can.
Wouldn't it be 6, 7, square root of 2?
Yes. So I can divide that fraction. So I have 12 divided by 2. 12 divided by 2 is just 6. Okay, so then my final answer here would be 6 times the square root of 2. No, we have another special right triangle.
Come on. You're killing
Okay,
me.
questions on 45, 45, 90 right triangles.
Oh no, we got 30, 60, and 90 right triangle.
Are we good? Did we get it all copied? All right, on the back then. Next, our next special right triangle we're going to talk about is 30, 60, 90. Okay, but to figure out that rule, just like I did on the front with the square, we're going to start with an equilateral triangle. Now, what do you know about an equilateral triangle?
It has equal sides.
It has equal sides. Okay, all 3 of those sides are going to be congruent to each other. Now, in an equilateral triangle, all of your angles are also congruent to each other. Okay, since all of the angles are congruent to each other, they're all 60 degrees. Okay, so just like in the square I drew in that diagonal to split it into 2 right triangles, I'm going to do the same thing with this triangle. So I'm going to split this into 2 right triangles. So to do that, I'm going to drop what's called an altitude straight down. Practice. Okay?
She's a math teacher.
You're going to draw an altitude straight down. When you do that, guys, we're done talking now. When you do that, it forms a 90-degree angle with the base of that triangle. Now, when I drew this altitude in, it split this top angle into 2 equal angles. So this other angle over here will be 30 degrees. Okay, so here I have my 30, 60, 90 right triangle. So just like before, I'm going to label my sides. So opposite the 90-degree angle is the hypotenuse. Now, instead of labeling the other 2 sides as legs, I'm going to label one side as the long side and one side as the short side. Okay, your short side is always the side across from your 30-degree angle. And your long side is always across from your 60-degree angle. Okay, so this is the short side. And this is the long side. Okay, so again, we're going to use the Pythagorean theorem to find a rule for this. So again, using a squared plus b squared equals c squared. Now, I'm going to label my short side as x, just like we did before. But instead of labeling the long side as x, that has to be a different variable because they're different lengths.
Y.
So that's going to be y. Okay, so plugging these in, I have x squared plus y squared is equal to the hypotenuse squared. Now I can't combine like terms here. I can't do a whole lot with this. But we started with an equilateral triangle. When I dropped this altitude, it split this side here into 2 equal parts. Okay, so the actual side length of my equilateral triangle, if I add those 2 parts together, would be what? If I add x plus x, it would be 2x. Okay, x plus x. Okay, so here, that entire side is 2x. Now, before when we started with that equilateral triangle, you said all of the sides were equal. So what does that mean the hypotenuse has to equal? 2x. So instead of hypotenuse, I'm going to label this as 2x. So here I have x squared plus y squared is equal to 2x. That quantity is squared. Okay, so I'm going to square 2 and square x. So x squared plus y squared is equal to 4x squared. Now I want all my x squareds together. So I'm going to subtract x squared from this side and this side. Okay, so I cancel them out over here. To get y squared is equal to 3x squared. Okay, I want y by itself. So I'm going to take the square root, both sides. Okay, when I take the square root of y squared, I get y. I can't take the square root of 3 perfectly, so I'm going to leave it as the square root of 3. But I can take the square root of x squared. Okay, that's just x. Okay, now I'm going to replace it with my labels. I labeled y as the long side. Okay, so we have the long side is equal to the square root of 3. That x value was labeled as the short side, so times the short side. That's going to be our rule for finding the long side of this right triangle. Okay, now if you're given the long side, you could also use this rule to find the short side, just like we did on the front. Okay, so you just plug in what you know to find that missing side. Okay, so the other one is the hypotenuse. The hypotenuse, you just have to multiply the short side by 2. So down below here, I do have the rules for you. To find the hypotenuse of this type of right triangle, you're going to take 2 times the short side. Okay? If you want to find the short side and you're given the hypotenuse, you're going to take the hypotenuse and divide it by 2 to give you the short side. The long side, which we just found, is equal to the short side times the square root of 3. If you're trying to find the short side given that information, you're going to take the long side and divide it by the square root of 3. Okay, so these are your rules for 30, 60, 90 right triangles. Now, if you are not given the short side, you always need to find the short side first. Okay? Okay, you always need to find the short side first because you need the short side to find the hypotenuse and to find the long side of this triangle. So always find that short side first if it is not given to you. So we're going to do some examples. Okay, so number 6. First identify that it is a 30, 60, 90 right triangle. I have 90, 60. This other angle has to be 30 degrees. From there, I'm going to label all of my sides. So first the hypotenuse across from the 90 degree angle. The short side is across from the 30 degree angle. And the long side is across from the 60 degree angle. Okay, now we're not given the short side. Okay, there's an X for the short side. You always need to find the short side first. Okay, so I'm going to look at my 2 short side equations here. Next, I'm going to look at if I have the hypotenuse or the long side. In my triangle, I have a number for the long side, meaning I need to use this equation to find the short side. Okay, I can't use this one because then I'm going to have 2 variables. Okay, I'd have x is equal to y over 2. Can't solve that. But I am given the long side, so I can plug in 15 for long in this equation. So I'm going to use this one here. Our short side is x. It's equal to, our long side is 15 divided by the square root of 3. Okay, from here you have a root in the denominator, so we need to multiply by a version of 1 And that's square root of 3 over square root of 3. Guys. Multiply straight across. So we have 15 times the square root of 3 over 3. Remember, when I multiply square root of 3 times square root of 3, you just end with 3. From here, I can divide this 15 by 3. What do I get? So our x value, or short side, is 5 times the square root of 3.
God.
We also have to find y. That's the hypotenuse. I'm going to look for which equation says hypotenuse equals. Okay, that's the top left one right here, because I want to find what the hypotenuse is. So I'm going to use this equation to find y. So plugging in what I know, y is the hypotenuse. Next we have 2 times our short side. Now our short side was x, but we just found what that x value is. So I can multiply by 5 times the square root of 3. Okay, so we have 2 times 5 is 10, and the square root of 3. Questions?
Why is there like 2 billion steps?
It's not 2 billion steps.
Close enough to it.
All right, next we're going to look at 7 then. Okay, so labeling our sides. Opposite 90-degree angle is the hypotenuse. Opposite 30 is the short side. And opposite 60 is the long side. Make sure you label those correctly. Okay, again, I'm not given the short side. I need to find that first. So I have 2 equations to find the short side. I need to know if I'm given the hypotenuse or the long side. Which one am I going to use? Long. I'm given the long side. So I'm going to use this bottom right-hand equation here. So plug in x for short side. That's equal to our long side is 12 divided by the square root of 3. Again, we want to rationalize that denominator. Get the square root out. So multiply by our version of 1, which is square root of 3 over square root of 3. Multiply straight across. So we have 12 times the square root of 3 over 3. Again, I can reduce this fraction of 12 over 3 to get x is equal to 4 times the square root of 3. Okay, I still need to find y. Okay, y is the hypotenuse. Which one of my 4 equations should I use? Top left. Good. Okay, so I'm just going to plug in what I know into that top left equation. So we have y is equal to 2 times our short side. I just found our short side. That was x. So that is 4 times the square root of 3. So y is equal to 8 times the square root of 3. Questions? Are we okay? Please ask me a question if you don't understand. To find the